Okay, everyone, we're going to look at number 15 in section 4.3. We're going to find the critical points and the interval in which the given function is increasing or decreasing and apply that's the first derivative test, to each critical point. And here's our function. They do want you to write critical points in increasing order, so they use this notation. C1 will be the smallest critical point, C2 will be the next biggest, and then C3 will be our biggest critical point. Okay. And these are the x values themselves, right? The x values are what, we're talking about. So first we take the derivative. Hopefully this is pretty easy by the power rule. X to the fourth, I bring the 4 down, times a negative 5/4 gives me -5. Subtract 1 from 4 gives me x cubed. Bring the 3 down, 25 thirds times 3 is 25. -25, subtract 1 from 3, I get 2. Bring the 2 down, 80x, subtract 1 to the first power, and the derivative 400x is 400. So to find out, our critical points are what? Where the derivative is 0 or undefined. So it's clearly never undefined because this is a polynomial and it's defined for all real numbers. But to find out where it's 0, we would want to factor. So I first note that there is a GCF of 5. I'm actually going to factor out a -5 because this first one's negative. So when I factor out that -5, I'm left with x cubed plus 5x squared. Notice it's -16 because I factor -5 out of a positive 80. That leaves -16x. And then a positive, -5 factored out of positive 400 is -80. I have 4 terms left over, so we should factor by grouping. Group the first 2. What can I factor out of those 2? Well, an x squared leaves an x and a 5. Out of the last 2, then, I want to be left with an x plus 5, so I have to factor out a -16, which leaves me x. -16 factored out of -80 is +5. And that's important that we get the same factor left over, because now I can factor this out, leaving an x squared minus 16. And x squared minus 16 factors as difference of squares. So I can quickly see then that this is the derivative, and it's going to be 0 when what? X is -5. I'm calling that C1. X is -4, C2, and X is 4, C3. So that has to be in order. So notice that's the smallest one. -5 is less than -4, and -4 is less than +4. We should then do a sign check on the derivative, right? And I make sure you put them in the correct order. The derivative is 0 at each one of these points. And I just check the value of this derivative right here. You can check here or the factored form. Plugging in numbers less than -5 gives me a positive derivative. Between -5 and -4, negative derivative, and so on. Okay, so you should check and confirm that. But this tells me now what? The function is increasing where and what? The derivative is positive. So on the intervals, everything less than -5, everything between -4 and 4. F is decreasing where the derivative is negative. So between -5 and -4, and everything greater than 4. And then by the first derivative test, we have a local maxima where what? The derivative changes from positive to negative. That's at -5 and at +4. Local minima occur where what? The derivative changes sign from negative to positive. That occurs at -4. Now, what they're asking for is, what's happening at these critical points. So we've kind of already talked about it, but at C1, which was -5, remember we have a local max because we're changing from positive to negative. C2, we have a local min, again, because we're changing from negative to positive in the derivative. And then C3, again, local max. All right, I hope this is helpful.